In this lecture, we are going to see about different scheduling algorithms. So the first scheduling algorithm here we are going to discuss is the first come first serve scheduling. So we will see what is first come first serve scheduling, how does it work, and if this is a good scheduling algorithm. So this first come first serve scheduling algorithm is by far the simplest CPU scheduling algorithm. And from the name itself, it is easy to understand that first come first serve scheduling means the process that requests the CPU first is allocated the CPU first. That means whoever comes first will be given the CPU first. So the first process that requests the CPU will be given the CPU, and in the second process will be given the second chance. The third process that comes will be given the third chance, and so on. It is very fairly a simple method that can be followed, and it is also a very simple method that can be implemented, and it is also a simple method to understand. So the implementation of the FCFS policy or the first come first serve policy is easily managed with the FIFO queue. So here first in first out is a very normal method that we follow in a normal queue. So what we mean by first in first out is the element that comes in first will be the element to go out first. That means the element that comes in first will be the element to complete its work and go out first. So it is very similar to the normal queue that we have in our day-to-day life. So think of a simple example where you are standing in a queue in order to pay your bills or something like in front of a customer. So what happens is the person who comes first will be given the chance to perform the activity first. So let's say that suppose the queue is for paying some kind of bills. So the person who comes first will get the first chance to go into the counter and pay the bill, and the second person will be given the second chance, and so on. Whenever a new person comes, he has to stand at the end of the queue or at the tail of the queue, and then this pattern is continued. So if we are following a very fair kind of queue, then a person who comes at the end will never be given a chance to go in first, or will never be given a chance to come in between any of the other members. He has to stand at the end of the queue. And also if we are following a really fair queue, then whoever is standing in the queue has to follow that pattern. Nobody will be allowed to take the chance until his chance arrives. So let's say that there are some all people standing, or if some children are standing very fair queue, they will give a chance to go into the counter unless their chance arrives. You cannot break this queue. So I am taking this example because in the first come first serve scheduling, this is what is going to be followed exactly. So keep in mind, as I told you, FCFS policy is easily managed by a FIFO queue. So this is an example of a FIFO queue where elements are queued up like this, and then the first element is known as the head of the queue and the last element is known as the tail of the queue. So when the head of the queue, which is this element, completes its execution and goes out, then this element over here will become the head, and if some other element come in, then they will be added to the tail of the queue. That means they will be kept over here and that element will become the new tail. So this is how a FIFO queue is followed, and by making use of this FIFO queue, this FCFS policy can easily be implemented because it is going to follow a first come first serve basis. So what happens is when a process enters the ready queue, its PCB is linked on to the tail of the queue. So we have studied about the different state that the process can be in, and we know that when a process is ready to be executed, it will be in the ready queue, and when it is in the ready queue, its PCB, there is a process control block, will be linked to the tail of the queue. If we are following a first come first serve scheduling, and then when the CPU is free, it is allocated to the process at the head of the queue. That means here we have a queue where the processes are queued up like this, and then they are all waiting for the queue. So the CPU is free, the process which is at the head of the queue, that means this process will be given the CPU for its execution, and then the running process is then removed from the queue. That means once this process gets to CPU, then this process will be removed from this queue because it has already got the CPU for its execution. So this process will be removed, and this second process over there will be the new head, and then if some other process come in again, they will be added to the tail, and that will be the new tail. So this is how first come first serve scheduling works. Now let us see if first come first serve scheduling is an efficient scheduling or not. So with the average waiting time under the FCFS policy. However, it is often quite long. So if we are following a first come first serve scheduling policy or a scheduling algorithm, then the average waiting time for each process is quite long.